We now consider this differential equation, that is y double prime plus 9y equals negative 3 secant 3t. So in part A, we determine the roots of the characteristic polynomial. So first, let's write down the characteristic equation using the homogeneous differential equation. So for this y double prime plus 9y equals 0, this is the homogeneous differential equation. The characteristic equation is r squared. We replace y double prime by r squared plus 9 equals 0. So let's solve this equation. R squared equals negative 9. Then we have to find all. So we take square root on both sides. So therefore r equals square root of negative 9. And this equals, we can write this as negative 1 times square root of negative 9. And so this equals square root of 9 is plus or minus 3, and square root of negative 1 is I. So we have r equals plus or minus 3i. Therefore, the roots of this characteristic polynomial r1 equals 3i and r2 equals negative 3i. In part B, we write the fundamental solutions to the homogeneous equation which we obtain in part A. So we write the fundamental solution yf, and this equals e raised to the power of alpha t times a cosine beta t plus b sine beta t. We'll now determine alpha and beta using the roots which we obtain in part A. So R1 and R2 equals 3i and negative 3i. Basically, these two are complex roots. So therefore, R is equal to 0 plus or minus 3i, and this is in the form of alpha plus or minus beta I. So alpha equals 0 and beta equals 3. Let's plug it over here. Therefore, the fundamental solution to the homogeneous differential equation y of this equals e raised to the power of alpha t, which is 0t, times a times of cosine, replace beta by 3, so it is 3t. This is cosine 3t plus beta sine 3t. And this simplifies to yf, which is the fundamental solution. E power 0t is 1, so we will not have to put 1. So it basically y a times of cosine 3t plus b times of sine 3t. And this is the fundamental solution to the homogeneous differential equation. And here we identify the term cosine 3t as y1 of t. And then the next term sine 3t, we identify this as y2 of t. So we write y1 of t equals cosine 3t, y2 of t equals sine 3t. In part C, we determine the Wronskian of the fundamental solutions that we obtain in part B. So we write Wronskian w of t, and this equals, it is a 2 by 2 determinant. In the first row, we write y1 of t and y2 of t. And then in the second row of the determinant, we write the derivatives, that is y1 prime of t and y2 prime of t. Basically, this is the determinant that we have to evaluate. So let's determine this Wronskian by replacing y1 of t with cosine 3t. This is cosine 3t. Then y2 of t by sine 3t. And so y1 prime of t will be the derivative of cosine 3t, which is negative 3 sine 3t using the chain rule. And the derivative of sine 3t is 3 cosine 3t using the chain rule. So we have to evaluate this determinant. So let's take the product of the diagonal. We then have to take the negative of the product of the diagonal. So this will be cosine 3t times 3 cosine 3t equals 3 times of cosine squared 3t. We then put negative, and then the product of negative 3 sine 3t times sine 3t is negative 3 sine squared 3t. But since we already have a negative, this will become plus. So it will be 3 sine squared 3t. And now we factor 3 from both the terms. So it will be 3 times of cosine squared 3t plus sine squared 3t. And using the Pythagorean identity, we replace this expression by 1 because sine squared theta plus cosine squared theta equals 1. If we replace theta by 3t, we will get this expression, so which equals 1. So this equals 3 times of 1 equals 3. That is Wronskian equals 3. And now we will also have to determine two more Wronskians, that is W1 of t, and this is also a 2 by 2 determinant. For this, in the first column of the W1 of t, we replace that by the first row by 0, and then the second row element by the function on the right side. That is, this term is the g of t. So we replace that over here, negative 3 secant 3t. So I write negative 3 secant 3t. And in the second column of this Wronskian, we put the same column as we obtained in Wronskian, that is sine 3t, 3 cosine 3t. So I write sine 3t and then 3 cosine 3t. We have to evaluate this determinant. So this will be, here also we take the product of the diagonal minus the product of the other diagonal. So 0 times 3 cosine 3t will be 0 minus, we have negative 3 secant 3t times sine 3t. This becomes a positive. So it is 3 secant 3t sine 3t. I replace this secant 3t by using the reciprocal identity, which is 1 over cosine 3t times sine 3t. And we can now combine these two. That is sine 3t over cosine 3t using quotient identity equals tangent 3t. So therefore this equals 3 times of tangent 3t. And this is W1 of t. Now let's determine W2 of t. This is Wronskian 2. And for this, this is also 2 by 2 determinant. We put the first column as it is, as we wrote in the W of t. So we put this column as it is. Cosine 3t, negative sine 3t, 3 sine 3t. So this will be cosine 3t and then negative 3 sine 3t. And the second column we put 0 for the first row, and this element is replaced by g of t, which is negative 3 secant 3t. We now evaluate this determinant by taking the product of the diagonal minus the product of the other diagonal. So this will be negative 3 secant 3t times cosine 3t. And so this equals negative 3 times secant 3t is 1 over cosine 3t times cosine 3t, And so these two gets cancel out, leaving us only negative 3. So we have determined that Wronskian 2 equals negative 3. In part D, we determined the particular solution to the non-homogeneous differential equation. That is, yp represents a particular solution, and this is given by u1 y1 plus u2 y2. So here we have to determine u1 and u2. So we write u1 or u1 of t, and this equals w1 of t over w of t. Let's say this is u1. So this is the formula that we utilize to determine u1. And so it's basically the quotient of these two Wronskians. That is, replace w1 of t by 3 tangent 3t divided by w of t is 3. This one is basically u1 prime of t. So let's put this as u1 prime. So here we have obtained u1 prime equals 3 tangent 3t over 3. And this means to determine u1, we have to integrate both sides. So let's integrate. And so this gives u1. And this equals, we can cancel these 3's. And this is integral of tangent 3t dt. And so here we can rewrite this as integral of sine 3t over cosine 3t dt. We now use u substitution method. Let's put cosine 3t equals u. So the derivative is negative sine 3t times 3 by applying the chain rule dt equals du. So I'm going to solve for sine 3t dt so that I can replace this over here. And so this equals, we are solving for negative sine 3t dt equals, let's say we solve for sine 3t dt. This equals negative du over 3. So therefore, after u substitution, this will become negative of this one. We replace this by du by 3 and divided by cosine 3t, we write this as u. So this can be rewritten as negative 1/3. We factor the constant and then du by u. So this equals negative 1/3 1 by u du. So the antiderivative of 1 by u is natural logarithm of u. So this one is natural logarithm of u. We can put using the absolute value. So now let's do the back substitution for u. So therefore this becomes negative 1/3 natural logarithm of u is cosine 3t. So we replace u by cosine 3t. And so therefore this one is u1. Now let's determine u2 using the formula, that is u2 prime, or this equals u2 prime of t. This equals w2 of t over w of t. So let's replace w2 of t by negative 3 and w of t by 3. And so this equals negative 1. That is u2 prime equals negative 1. So to determine u2, we find the integral on both sides. So we get u2 prime, I'm sorry, after integration this is u2, and this equals the antiderivative of negative 1 is negative t. And so this is u2 or u2 prime, u2 of t. Okay, now that we have determined u1 and u2, we can write the particular solution using this equation. So we replace u1 and y1 as well as u2 and y2 using the equations that we have already determined. So we write yp, which is the particular solution to the non-homogeneous differential equation. This equals u1, which equals negative one-third natural logarithm of cosine 3t times y1, which is cosine 3t, plus u2, which is negative t. So I write here negative t times y2, which is sine 3t. And so this is the particular solution to the non-homogeneous differential equation.